What is it? Um, Power is an expression and exponent is just a part of it. So that's the very simple difference or definition for your understanding. You can understand it like that. So power is altogether what is the expression is, and the exponent is just part of it. This is the example. So this is the power full a to the power m. So this is an expression where exponent is just m, is just a part of it. So this whole term is a power representation where a is called base and m is called exponent. So that clarifies it. Next, now we will know what are the properties and laws of exponents so that we can do some problem solving for our clarity. So, okay, so this is just a bullet point. Don't confuse it with the negative sign. So a to the power m multiplied by a to the power n equal to a to the power m plus n. Next, similarly, a to the power m divided by a to the power n equal to a to the power m minus n. So when it is multiplied, the exponents got added uh, because the base is same. And when the base is same and it's divided, then the exponents are going to be subtracted. Next one, so when it is power to power, then it could be also represented as the simple multiplication a to the power mn. This is saying a different property where the exponents are same, you can multiply the bases. And this is a very important thing that you need to remember when the base, whatever may be the base, if the power is or the exponent, sorry, the exponent is 0, then the value is 1. This is again same thing, same operation. Bases are different, exponent is same, so for division the bases will be divided. Next one. So it's just saying motive small fraction numbers can be expressed in standard form using negative exponents. So this is saying, okay, so this is a fraction number, but we can represent it with the expression of exponents. So you see, reading it is quite difficult, but if you represent it like this, it says 3.2 multiplied by 10 to the power minus 8. So this is easier to represent. As I was saying, fractions can be easily represented using these exponents. Now let's solve it. Here we have the exponent is same, it's multiplied. So we will multiply the bases keeping the exponent same. Okay, and this is going to be 4 times multiplying minus 3, it will, so minus will go away, it become positive, and the value is 81, positive 81. Again it is coming like this where same, it's same exponents, and this is the value coming out to be. Now this could have minus only if the exponent is an odd number. If the exponent is even, so that's why minus 5 to the power exponent raised to 4 is 625 plus 625. So that's what. So that is a very simple explanation of exponents and powers, what are the properties of exponents and powers, and how to solve the problems. Next one in this series we have proportions, which is going to just explain what are the proportions. It's directly proportionate or indirectly proportionate, like not indirectly, like inverse proportion or direct proportion. Direct. Two quantities can be said in direct proportion if they increase in such a way that the ratio is always a constant. So they are directly proportionate if the ratio is a constant. Example, if two variables a, b are such that a by b equal to k, then you can say it's directly proportional. That's the simple way to remember what is directly proportionate. Indirect. Two quantities are called inversely proportional if an increase in one causes proportional decrease in the other. So that's why it's inversely proportionate. Now how it is? So it's saying variables mn are there if mn equal to k. So that means where k is a constant, but what it is saying is when the proportionate is such a way that if m increases, n decreases, and k is always a constant. So it is also giving you example. Let's say for value of m equal to m1, value of n equal to n1 equal to m2 multiplied by n2. So these are different values. So it says for different values of m and n, they are always constant. Just another way of make the understanding clear. This is called indirect or inversely proportionate. Examples. So in this example, we are going to say, okay, m takes 20 minutes. So just understand the problem and then figure out how using these proportions we will solve it out. M makes 20 minutes to reach school when speed is 12 kilometers per hour. Okay, what should be the speed if time taken is 12 minutes? So it's saying speed is there, it is, but the so whatever distance is same. Okay, so when speed is 12, time taken is 20. Okay, now if he wants to take 12 minutes time, how much the speed? Now we know here distance equal to time multiplied by speed. So distance is the constant here. So 20 multiplied by 12 is the distance, that equal to 12 multiplied by what should be the speed. So that's how you can represent this proportion. That makes easier to calculate. So if you want to decrease the time, you need to increase the speed. That's how it is. They are kind of time and speed are inversely proportionate. So S equal to 20. Next, if x and y in proportion below, it's showing x and y. Okay, so it's just showing okay, x and y are in proportion. So when x equal to, that means they are in direct proportion, because when it is 4 it is 24, when it is 10 it is 60, when it is 7 it is 42. This factor of 6, that's what it's showing. Okay, next problem. To cover a distance of 80 kilometer, one has to go 50 miles. How many miles one has to go to cover 200 kilometers? So this is just a conversion problem, right? So it's saying that 50 miles equal to 80 kilometers. Now, if somebody is saying 200 kilometers, then how many miles is it? Simple. So that means 1 kilometer equal to 5 by 8 miles. That's how they are calculating. And then 200 kilometers equal to, so 125 miles.